Hi, everybody. I'm Joy Ting from the Virginia Winemakers Research Exchange, and I'm here with Harvest Tips for Winemakers. Tip number 7, monitor fermentations every day. During harvest, things can get really busy, and sometimes the lab work goes by the wayside. But no matter how busy you get, it's always worth the time to monitor each of your fermentations every day. Monitoring fermentation includes measuring both the sugar level as Brix or density and the temperature. It's also an opportunity to smell and taste the juice. During active fermentation, use a hydrometer to measure sugar, not a refractometer, as dissolved CO2 will alter Brix values from the refract. For red wine fermentations, you'll get the most consistent data if you measure just after cap management, when things are well mixed. Set up your data sheet so that you can easily see how things are progressing each day. If you use a spreadsheet program like Google Sheets or Microsoft Excel, the program will also plot the data into a curve to help you visualize the rate. This slide shows a relatively normal fermentation curve. Just after inoculation, yeast need to adjust to the environment of the juice. It's okay if you don't see sugar depletion for a day or so. Once they have adjusted, yeast cells begin to divide rapidly so that the overall number of cells increases exponentially. They also start converting sugar during this phase. This leads to noticeable sugar depletion. Fermentation also produces heat, so the temperature will rise. In red wines, this is when the cap forms. About 1/3 of the way into fermentation, the yeast reach a maximum population size. There are a lot of cells all fermenting at once, causing rapid, sustained sugar drop. All that fermentation produces even more heat, so that temperature hits a maximum about halfway through Brix depletion. As sugar is used up and alcohol accumulates, the rate of fermentation eventually slows down. You will often see temperature start to cool at this stage. Ideally, fermentation continues until all of the sugar has been used up. Keep in mind, Brix and density are calibrated based on the density of water. Alcohol is less dense than water, so a totally dry fermentation will have negative Brix or a density less than 1. Unfortunately, fermentation doesn't always follow this path. If we focus just on Brix depletion, we can see a number of different ways that things can go wrong. The blue line here represents our normal fermentation. The orange line represents a fermentation with a long lag phase. This is an indication that the yeast are not off to a good start. Long lag phase is a time when other organisms may be active. Some of these may cause spoilage. The most common spoiler at this stage is the non-Saccharomyces yeast Hanzeniaspora uverum, also known as Clochera apiculata. This is a yeast that's relatively resistant to SO2 and relatively active when it's cold. It's much more prevalent if the fruit has just been through rain. If there is oxygen around, Hanzeniaspora can form ethyl acetate, which smells like solvent or nail polish remover, as well as acetic acid. If you have a fermentation with a long lag phase, smell the top of the tank or bin. If you smell any ethyl acetate, gas the tank thoroughly and get the fermentation going as quickly as possible. CO2 will displace oxygen, limiting the production of ethyl acetate. And a little bit of alcohol goes a long way to reducing metabolism. Another thing to be aware of is if fermentation is going too quickly. The ideal rate of fermentation depends on your winemaking goals. However, if the fermentation is fast, like the one shown here, there are a few things to keep an eye on. Fast fermentations often deplete nutrients more quickly, leading to very reductive environments for the yeast. If you see this shape of a curve, you may want to check if the fermentation has sulfur-like off odors. These might smell like sewer gas, raw eggs, cabbage, or onions. If you catch it before 1/3 Brix depletion, you can often remedy the situation with a quick nutrient addition. Aeration will also help, both to mitigate the aromas themselves and to help prevent further formation. Fast fermentations are also hot fermentations. This might be desired in a red wine ferment where you're trying to extract phenolics, but maybe not so much in a white wine ferment when you're trying to preserve aromatics. Monitoring fermentation temperature along with the Brix will help you to see if you're cooking too hot. If you're in a temperature-controlled tank, hot, fast fermentation may be an indication of a failed control system. If you're fermenting in barrels or T-bins, it's an indication to move those vessels to a cooler location. Another problem you should be on the lookout for is a stuck fermentation. These really come in two types. The one shown here progressed well, but started to slow down too soon. In other types, the fermentation might be slow throughout, with the slope of the curve flatter than normal. Either type of fermentation has the risk of not finishing and leaving residual sugar for spoilage organisms to consume later. Oftentimes, stuck or sluggish fermentation also indicates stressed yeast, and stressed yeast often produce more acetic acid and fewer varietal aromas. The remedy for stuck or sluggish fermentations depend on the cause. There's an excellent review paper called Diagnosis and Rectification of Stuck and Sluggish Fermentations, written by Linda Bassan and Christian Butsky. I'll put a link to it on the WRA website. But before you can diagnose and remedy your situation, you have to know that you have a problem. So remember, monitor your fermentations daily.